All right, everyone. So this is step 2, where you're going to learn how to identify and define the rate of change. So the first thing you want to ask yourself is, why are we learning about rate of change? So you want to think about Earth. Now, when you think about Earth and even, the year, we say there's 365 days each year. That's a rate of change. That's how many days it takes for the Earth to go around the sun. We use rate of change when we're cooking. When we say how many cups of cheese and how many slices of pepperoni do we put into a pizza, that is also a rate of change. And most commonly, we also use rate of change when it comes to money. How much money you make each hour at your job, or how much money you make in total at the end of the year. These are all rates of change. So the reason why we learn about rate of change is because we use it every day. So we use rate of change every day. From your cooking, from how many hours you sleep, to how fast your car goes. These are all rates of change. So you're probably asking yourself, okay, what is rate of change then? Especially, how are we going to be using rate of change in math? So you'll notice that there is a take note symbol here. So you want to be writing what I'm writing down either in your notebook or in the learning bundle document that you have up in another tab. So once again, I'm going to give you a few seconds to grab a notebook where you can take down your notes by pencil, or make sure that you have your learning bundle document ready to take down these notes. So let's begin. What is rate of change? So here I have a formula that we represent rate of change with in math. It might look a little overwhelming, but don't worry, it all makes sense. So this capital R is basically another way to write rate of change. This triangle Y, this triangle is actually called the delta symbol. This is basically just a really short way to say change in. So when you see a triangle, just assume that it means change in when it comes to these math problems. So this triangle, or delta Y, basically means change in Y, and then is change in Y over or divided by change in X. Now, what does this mean? Right? So ultimately, and you want to write this down with me, rate of change is a ratio. And you learned about ratios in middle school. A rate of change is a ratio. I like to think of it as a fraction, right? It's a ratio that compares the change in Y, or you know that from our unit 6 that change in Y is actually our output. So change in outputs. And so we're comparing the change in Y to the change in X, which are our inputs. So this is our rate of change, and there are a lot of different ways that we can represent rate of change. So there is, change in Y over change in X using the delta symbol. But more commonly, what we do like to represent rate of change is, especially with linear functions, is with m. So rate of change can also be represented by the letter m. And we know that it means the change in y over a change in x. So I'm going to use the delta symbol, change in y over a change in x. Another way to write this is change is basically difference, and you're going to see this in the next problem. But what we can say, it's a difference between two y values. So we want to show the difference, so we're going to say y2 minus y1 over x2 minus x1. So this is basically saying there's just a difference between the y values divided by the difference between the x values. Another way to represent rate of change is rise over run. And we'll learn that when we look at the graph and in later steps. And then last but not least, we can also think of it as slope. So rate of change is actually very, very important. You're going to be using it in all your math classes. So it's really important that you have these definitions down. So I'm going to give you a few seconds to finish writing these notes. Make sure you have the definition here as well as all the formulas here. Okay, feel free to pause the video. I'm going to assume that you paused the video and unpause it to continue on. So let's see how this applies to real life. All right. So when you see this human with the little magnifying glass, I want you to really just observe, to watch what I'm doing. So you don't necessarily have to take down notes, but it's really important that you're really asking yourself, why is Miss M doing it this way? And what does that mean? And if you have any questions, always pause the video, rewatch it, slow it down, or even Google it yourself, okay? So let's begin. So further, we have this word problem. Every day, you take your dog out on a walk in the morning and in the evening. How many times did you take your dog out on a walk over 5 days? What is your rate of change? So we have our word problem, we have our information, and now we're trying to figure it out. And there's a lot of ways to do this, but this is how I'm going to solve it. First thing first, I am going to think about how to what information is important. So it says every day you take your dog out on a walk in the morning and in the evening. And I think that's really important. So we go in the morning and in the evening, and we're trying to figure out how many times we walked the dog over 5 days. So we can do it, by kind of writing it out day by day. So if I say, I can make a little T-chart or like a table chart. So I'm going to make this my X, and I'm going to make that my Y. X is going to be my days. My Y is going to be number of walks. Okay. So if I didn't before I start the day, I didn't take out my dog for a walk, so 0, 0. On the first day, how many times did I take my dog out for a walk? Once in the morning, once in the evening, so that's 2 times. After the second day, how many times did I take my dog out in total? So that's 2 days. So there's 2 mornings and 2 evenings. So total is going to be 4 times I took my dog out. On the third day, I took my dog out 6 times. And you notice the pattern here. On the fourth day, I took my dog out 8 times in total. And then on the fifth day, I took my dog out 10 times. Okay? So what does this mean? When you see a table chart, it's really easy to figure out what the rate of change is. So once again, remember, right? Rate of change is the change in Y over change in X. So there are a couple ways I can do this. What I first can think about is, what's the pattern? How much am I increasing my X by? So this is pretty easy. I'm going up by 1. How about here for my Y values? I notice that I'm going up by 2. So if I wanted to figure out my rate of change, which I'm going to represent as M, it's going to be the change in Y over change in X, which is just going to be 2 over 1. So basically we take the dog out 2 times for a walk each day. 2 walks, 1 day for each day. I can also use this other formula, which is going to be y2 minus y1 over x2 minus x1. And I'm going to be picking 2 points and solving it that way. So I'm going to do 2 minus 0, 1 minus 0, and that also gives you 2 over 1. How can we graph this? So each of these are points, right? So what would be our x-axis? What would be our horizontal? So if this is our x and our y, we know our x is going to be represented by days, and then our y value is going to be the number of walks you take your dog on. And I'm just going to go up by 1. it's going to go up by 1. So once again, at the beginning, it's 0, 0. One day I take my dog out twice. On the second day, I took him out 4 times in total, 3, 6, 4, 8, 5, 10. And you notice that it actually forms a line. So this is an example of a linear function. So this is another way where you can represent this basically this word problem. So if we want to answer this question, we know that you took your dog out 10 times. We walked the dog 10 times over 5 days. And the rate of change is going to be 2 over 1. And that's going to be really important as we move forward, trying to figure out how we can solve for this. So just as a recap, if we're looking at a table, you can literally just think about what the pattern is. We notice that the x go up by 1, the y's go up by 2, and that's how we were able to figure out that our rate of change is 2 over 1. We can also use the equation y2 minus y1 over x2 minus x1. I basically just took 2 y values, subtracted them, and then which is 2 minus 0, and then 2 x values, 1 minus 0, to get 2 over 1 again. And we'll learn more a little bit about rise over run. That's if I was looking at this graph. You notice that we go up 2 and over 1 to make these points. And that's how also you would get 2 over 1. But don't worry too much about that. What you really need to remember is that it is a ratio, it is a fraction. You're comparing the change in your y values or your outputs over the change in your x values or your inputs. So please remember to complete the check for understanding in step 3 in your learning bundle. Please rewatch this video as many times as you need to understand. And of course, if you have any questions, please reach out to me and I can help you understand. All right. Good luck.